Chapter 4, Section 26, De-duplication, Part 4, Automating the duplication process. Duplicate records pose significant challenges in data management, leading to inconsistencies, redundant storage, and inaccurate analysis. We need to move beyond manual inspection to handle duplicate records effectively and implement an automated de-duplication process. Automation ensures efficiency and improves accuracy by applying consistent rules across large datasets. The key to successful deduplication lies in developing a structured pipeline that processes data systematically, allowing for both resolution and traceability of modifications. Pipeline approach for deduplication. An effective deduplication pipeline involves three essential steps: applying resolution rules, automating data cleaning, and ensuring proper storage of deduplicated records. Before automating deduplication, it is necessary to define clear resolution rules that dictate how duplicates should be handled. These rules depend on the context of the data. For example, in customer databases, should the latest entry be retained or should fields be merged to keep the most comprehensive record? In transaction logs, should duplicate entries be aggregated or removed entirely? In research dataset, should missing values from one record be filled using another duplicate entry? Consider a dataset containing multiple entries for the same person, where we want to retain the record with the most recent update. First, using toDateTime, convert the UpdateAt column to be recognized as a datetime type in Pandas. Next, sort the dataset by UpdateAt column in descending order. Then, we retain only the most recent entry for each ID. This approach ensures that duplicate records are resolved systematically based on a clear business rule, in this case, keeping the most recent entry. Once resolution rules are defined, the next step is to automate data cleaning operations. The Pandas and scikit-learn libraries in Python provide tools to efficiently process duplicates. In addition to direct removal, deduplication often requires merging similar records. This can be done by computing similarity scores between entries using fuzzy matching. For example, if names are misspelled but refer to the same individual, we can use the fuzzy-wuzzy library to measure string similarity. This code uses the fuzzy-wuzzy library to compare two names and calculate their similarity score based on the Levenshtein distance. The names Theodore Roosevelt and Teddy Roosevelt are given as input. The fuzzy ratio function computes the string similarity percentage by measuring how many character edits are needed to match the two names. The computed similarity score is printed, indicating how closely the two names resemble each other. This method is useful for detecting potential duplicates when exact matches are not feasible due to spelling variations or abbreviations. A high similarity score suggests that the records might be duplicates and should be merged rather than deleted. Automated deduplication must ensure that modified or merged records are stored in a way that maintains traceability. This is particularly important in domains such as healthcare, finance, and legal systems, where data changes must be auditable. To preserve original data integrity, one approach is to maintain a mapping table that logs how records were merged or removed. A simple way to achieve this in Python is by storing log files or metadata tables alongside the cleaned dataset. This code logs remove the duplicate records and saves both the clean data and the removed duplicates as CSV files for auditing purposes. This line extracts the rows from the original dataset that are not present in de-duplicated data. This effectively identifies and logs the removed duplicate records. This code saves the removed duplicate records into a CSV file named duplicate_log_CSV. The parameter index equals false ensures that the data frame index is not included in the output file. This code saves the cleaned dataset to clean data CSV. This enables us to easily reuse the de-duplicated dataset in further processing. This approach ensures traceability and transparency by keeping a record of removed duplicates while preserving the cleaned dataset. While custom-built de-duplication pipelines provide flexibility, pre-built tools like the Record Linkage Library offer advanced capabilities for entry resolution and record matching. This library is particularly useful when working with large-scale datasets where traditional rule-based approaches are insufficient. The Record Linkage Library enables probabilistic deduplication, meaning it can compare multiple fields, for example, name, address, and phone number. And it assigns a probability score to indicate whether two records refer to the same entity. Let's see an example that uses the Record Linkage Library to automatically detect duplicate records in a dataset. This process is called record linkage, which helps identify the same entity across different datasets or within large databases. First, import the record linkage library, which is used for record matching and duplicate detection, and display the dataset again just for confirmation. Next, initialize the indexer and apply blocking. First, create indexer to manage the record linkage process. Next, block name ensures that only records with the same name are compared, reducing the number of pairwise comparisons. This step improves efficiency, especially for large datasets. Next, create candidate pairs for comparison. This code generates a list of candidate record pairs that should be compared based on the blocking rule. This output indicates that these pairs of row indices from the data frame will be compared. 2-1 means the pair of dflog2 and dflog1. 4-3 means the pair of dflog4 and dflog3. Next, let's compare name and email fields using similarity matrix. First, creating a record comparator. This code initializes a comparison object that will define how the records are evaluated. Next, define name and email comparison rules. Names are compared using Jarrow-Winkler similarity with a threshold of 85% or higher. Emails are compared using exact matching, since email addresses are less likely to contain variations. Next, calculate similarity scores for each candidate pair. Finally, let's output the record pairs with high similarity scores, that is, sum is larger than 1. High similarity scores represent duplicates. These pairs of numbers represent the pairs of the records. The column 0 represents name column, and its value is a similarity score. The scores are 1, indicating that these pairs have 100% similarity. The column 1 represents email column, and it also shows that these pairs have 100% similarity in email address. Thank you for watching. Please thumbs up and subscribe to my channel.